All right. Hi, everyone. We are hosting today Emmanouil Tranos from University of Bristol, who will be having the talk about how internet connections, yes, am I right? So this high-speed internet connections imply the productivity. So floor is yours, Emmanouil, and thank you for being with us today.
Pleasure. I don't think I can share. Oh, yes, I can. Sorry. Yep. Give me a sec. And you should be able to see my screen now if I have it right.
Yes, we are able.
Awesome. Okay. Well, thank you very much for being here today. Thank you very much for inviting me. It's a great pleasure to present our ongoing work with my good colleagues Tassos Kitsos and Levi Wolf. So what we're trying to do in this paper is to actually unpack this quite complex relationship about the potential film productivity effects that internet and internet connectivity can raise. And we do that using what we believe is a rather novel research framework, which involves some interesting micro data about experienced internet speeds. And I will, of course, explain as we move on what I mean with these terms. So the structure of the presentation, I will start by introducing the problem. I will very briefly touch upon some previous findings, and then I will jump on to the data and the methods that we use for this paper. I will present our results, the outputs of our econometric modeling, and I will close with with a summary of what we believe that we achieved with this paper. So, a disclaimer: I need to thank ONS and the UK Data Service because they provided to us access to this unique film level data that we use for our analysis. All the analysis took place within a secure server, a secure environment, so no data leakages, no identification of individuals. We are thankful to ONS and UK Data Service for providing this infrastructure. So, I think the headline of our work is this relationship. So we're trying to understand whether internet, whatever internet means, and we will, further dig into it as we move on, can generate any type of any economic effect. So this is not a COVID paper. Actually, the data we use ends just before COVID, but this is a paper that one was inspired, and two, we started working on this paper during the COVID pandemic because of all the discussion we had during that period regarding the potential effects, how all this working from home can break or not the internet. And I think all of you who remember that time, you could easily relate to this picture, trying to work from home, being online, but still your internet connection wasn't that good. You had breaks in your communications, in your Zoom calls, and all of these things. So the layer we're trying to add into this, long-standing exploration between internet and economic effects is the quality of this internet connectivity. In general, there is a great discussion about the potential economic effects of any type of digital infrastructure. even if we go back to early 90s, there was a discussion about the Salo paradox. Computers at that point were everywhere, but the productivity statistics. So despite the high penetration of computing facilities, back on the day, productivity effects because of this of computers of digitalization was very slow to kick in. So on the one hand, we have this kind of productivity puzzles. On the other hand, we have quite some great expectations from both the policy and the user's perspective. So all in all, this is a hotly debated issue, right? And as I will show you later on, it's also a hotly debated issue within the literature. So why do we expect that the internet can generate any form of economic effects? We know from the literature that the internet and more broadly digital technologies, one, can increase the amount of information, right? And by doing that, this can improve the efficiency of markets, decision making, and even resource allocation. They can also speed up the diffusion of knowledge and to a certain extent, enhance innovation. If we assume that our paper produced any type of new knowledge, the fact that you guys and myself talk via Zoom can be an illustration of such a diffusion process. And more broadly, I think we will all agree that digital technologies, and more specifically the internet, reduce transaction costs, communication costs, which at the end of the day might lead to more competitive products and services. So this was the high level, if you prefer, pathways through which we expect that the internet can lead to some kind of economic effects. There is a lot of nuance on how we understand this internet or how we construct such an internet variable. So from an empirical perspective, we have seen in the literature various ways and various levels through which digital infrastructure or digital systems, and more specifically the internet, have been conceptualized. So we've seen, for example, research focusing on at the micro level, that is the firm level, and the economic effects that firms experience through such technologies. We've seen work focusing at the meso level, cities and regions, and what is the more aggregated, if you prefer, effect that cities and regions can experience because of better internet infrastructure. And of course, we have seen work at the macro level, focusing on national economies. So what are we trying to do? We're trying to assess the effect of the quality of internet infrastructure on firm productivity. This is the part of the economic outputs that we're primarily interested here. I highlight the element, the quality of the internet infrastructure, because we're very much interested in capturing the best we can the experience that internet users go through, how well or not good enough is the internet connectivity that internet users actually experience. And in order to do that, we use some data. We believe it's novel. It has been used before in the literature, but as you will see later on, we do something that can help us unpack. We use it in a way that can help us unpack the business usage or approximate better how firms have been utilized internet connectivity. So the data we're using is micro data of experienced internet speed through a company that provides internet test services. And I will explain as we move on what this exactly means. So we're able to capture the business internet users and also consider local characteristics. And after doing all of these things, we're in a better position to capture the effects of the experienced internet speed or the quality of the internet infrastructure on firm productivity. So we're focusing on a period between 2011 and 2019. I think this is a great period because the internet users was already stable during that period. It was after the point that the diffusion curve had flattened. So we and businesses, were able to more effectively utilize the potential economic effects through this infrastructure. So let me quickly go through some previous work, and I'm structuring, this brief literature review based on the different levels that that research has taken place. So starting from firm level research, we've seen, various studies that highlighted, positive effects of broadband availability on the employment and maybe turnover of businesses. There is an urban bias, and also there is a question about how short-term and medium effects of broadband availability. At the meso level, and this is the level that I'm personally more familiar with, we've seen a lot of work highlighting various positive effects, positive relationships between ICT infrastructure and employment or wage growth, broadband availability, and attraction of knowledge-intensive business services. We saw a work focusing on different interregional inequalities because of which has been what are associated with internet infrastructure at that meso-regional level. We've seen also some positive effects on economic development. And also there is in the literature quite some discussion with location preferences of new firms. I'm going to skip the macro national level because this is not that much related to what we're doing here. What is interesting to highlight, though, is the different metrics that researchers have utilized to capture the internet variable that I mentioned in the beginning. I think the great variety of different proxies for the internet, in essence, reflects the story of my life, if you prefer. Most of my work has to do with digital technologies and how digital technologies interact with cities and regions. And if you want to do this type of research, there is hardly any official data that can help you effectively capture any facet of our digital, the usage of internet, of digital technologies. Therefore, researchers were forced to be more creative and try to find different proxies to capture different facets of the digital infrastructure. So people have used internet subscriptions, the share of population with an internet connection, mobile phone subscriptions, or more specifically, and later as we moved on, internet broadband connections. In previous work, we used the number of commercial websites per region to capture the engagement with the digital. So you can see there is a great variety a great number of different approaches or different proxies to understand how digital connectivity is experienced by users. More recently, the focus in this type of work has moved from the availability of broadband connectivity to metrics that better reflect the quality of such connectivity. So there is a lot of work that has been focusing on the internet speed, and quite some time ago, this was highlighted as the new frontier of the relevant empirical research. So at the country level, we have seen positive effects of internet speed on economic output. We have seen research focusing on jobs, incomes, and earning, and we've seen that broadband speeds maybe are not linked to these output variables, especially in the US. On the other hand, we've seen advertised broadband speeds being related with a reduction in unemployment, and also on another paper was not able to identify a positive effect on productivity in US counties. Importantly, the last paper found some positive productivity effects when they've used advertised internet speed. So let me explain, what we're doing, the data we're using, and also highlight these terms I kept on using: advertised or experienced internet speed. So if you set up a new internet connection at home, usually you have to choose between different levels of speeds, how fast you want your internet to be. This is the advertised internet speed. This is how your internet service provider advertises the connectivity package they sell. However, the advertised internet speed is hardly ever equal to the speed that we as internet users experience. And there are various reasons, for this. It might be because of bottlenecks, and these bottlenecks might be localized because a specific cable might be down. It might be bottlenecks because of specific temporal effects. So it's 8 o'clock at night and everybody wants to watch Netflix. So everybody's consumes a lot of bandwidth for video streaming. So long story short, these advertised speeds are hardly ever equal to the experienced speeds. And aside from these, temporal effects, the Netflix effect, there are times that there are specific problems with a network and connectivity is down. And this, you can imagine, this instability might have adverse effects on internet, on economic output, and most importantly, it is never captured by the advertised internet speeds. This is exactly what we are doing with our data. We're using microdata about internet speed tests using the Speed Checker website. So this is a widely used service in the UK. You go to that website and you can test how fast or how slow or how stable your internet connectivity is. So we have the stream data set of individual internet speeds from between 2011 and 2019. This is a much larger sample than the more official internet speed data we have in the UK, and we believe that's a better representation of the actual picture of the internet infrastructure. Importantly, this is timestamp data, so we know when exactly these internet speeds took place. We also know the location of these internet speeds, at the postcode level. But the important element here is, the timestamp, because using this timestamp, we're able to filter this data and only consider data points or speed tests that took place during working hours. And therefore, we're able to capture better, and we believe better than previous studies, the business-related experienced internet speed. So we're not the first ones that we used such experienced internet speed data before, and I have here a few examples of previous work that used such data. But again, this filtering that allow us to capture the business, related internet experience is something that has been introduced in this paper. So what do we do with these data? Although we can geolocate this data at the postcode level, we cannot directly match it to a specific firm. Therefore, we took a decision to aggregate these data at the local authority level and create metrics at the local authority level regarding the internet quality. We call these metrics the digital environment within which firms operate. It makes sense, we think, to create such variables at the local authority level because also of the localized, of the potential bottlenecks of the internet infrastructure that more often than not tend to be localized. And of course, the reason behind this lies on the network topology of the internet infrastructure. Another rather novel thing that we're able to do with these data is that we can capture both upload and download internet channels. And as you can easily imagine, different internet channels can reflect different types of internet users, downloading large files or streaming and synchronous communications. So we are calculating the median internet upload and download speed for every local authority in the UK at a yearly basis. And we also, and of course, this is these variables capture, the level of speed, if you prefer, but we also calculate the interquartile range for upload and download speeds at the local authority level for every year. And these variables reflect the stability of the internet connection. And although previous studies have tried to capture, the internet speed, there is hardly any work that focuses or also considers the stability of the internet connection. And as you will see, in our first results, this is important when we try to capture the overall effect of the experienced internet speed. So once we create these local authority digital environment variables, we match our local authority metrics with individual firm records. And to do that, we use firm microdata in the UK. This is the official data about firms, the business structure database between 2011 to 2019. We use this data to create our dependent variable, which is productivity, firm productivity, measured as revenue per worker. And we were also able to use this data to create other important control variables about firms, like the age of the firm, the sector they operate, the size based on employment, and of course the location of these firms, which allow us to spatially match firms, like individual firms, with a local authority variables about the digital environment. So we use all of these data to estimate multi-level models. Our dependent variable is productivity of firm I, which is located in local authority J, which operates within sector S in year T. And we explain or we predict this variable, or we test the effect, if you prefer, of the different internet speed variable on this productivity of a specific firm. Our models also include local authority characteristics, the firm characteristics that I mentioned before, but importantly, because we estimate these models as multi-level models, our models account for placial characteristics. This is the effects of local authorities using the random intercepts. We account for specific spatial characteristics, and these are captured by the local authority variables. We account for within firm characteristics because we have firm level intercepts. So this would be I instead of T here. And we also have we account for within sector characteristics because we have sector level random intercepts. So this was a rather complicated model to estimate, and it took hours for every regression. So I have to admit it wasn't fun. So we have our starting point, the internet speed data, is more than 5 million data points during working hours and days during that period. So for every local authority, the median number of data points was above 12,000. If we plot the number of internet speed tests during working hours and days per local authority, we see a picture that we're not surprised. At the right end of the distribution, we see Cornwall, which is a known place for a rather limited internet infrastructure. We see some very populated, like highly populated local authorities. And then we see at the left end of distribution, places that are very sparsely populated. Interestingly, we see quite high correlation between the number of internet speed tests during working hours and days and the number of firms in local authorities on a yearly basis. And for some years, this correlation reaches 0.9. This is a plot of the median experience internet speeds, per local authority. Every line here is one single authority. We see that a well-expected upwards trend, both as far as concerned the download and upload speeds over time. Not extreme outliers, which is not the case when we focus on the interquartile range. So when we consider the stability of the internet connections, we do see quite a few outliers. And if I'm not mistaken, this is the City of London, which according to our data, and also according to people, the experience of people who live there, stability is not, internet stability is not something that the City of London is proud of. Importantly, if we had used advertised internet speed data, so data from internet service providers, we wouldn't have been able to capture, this extreme outlier. So this is a table of our descriptive statistics, all the variables we use in the regressions I'm going to present, and maybe it's better to move to the results instead of focusing on the descriptives. So all the regressions I'm going to present includes our estimated multi-level models, as I mentioned before. So the dependent variable is the log revenue per worker. They include 3 different random intercepts at the firm level, at the local authority level, and at the sector level. All of these regressions include yearly dummies, and also they include a number of control variables that are excluded from this slide in order to make it readable. I will go to the controls later on. So we started by including, by regressing the median upload speed and all the controls that I will discuss later against the productivity, the firm productivity, and we see as expected a significant positive effect when we focus on the upload speed, and this is what you see on the first column. The second column, we introduce the median download speed, and again we see a significant positive effect. Interestingly, when we test both these speeds, the results are not stable. So we see a negative effect on the download speed, which is, although it's not unique in the literature, we found different studies that had some similar effect. For us, is an indication that this specification that we see in the third column is not complete, doesn't provide the complete picture. And why? Because we are actually missing the stability element, the how stable internet connections are. And in order to account for this, in the fourth column of this table, we introduce the IQR for both upload and download speeds. And we started seeing here, some negative signals as we are expecting. So all in all, we expect that we believe that a better way to capture, these diverse effects of the interconnectivity is to account for all of these different phases of the internet, both the upload and the download channels, both the internet speed, but also the stability of the connection. And when we do this in column 5, which is our base regression and our preferred specification, we see some results which actually, make sense. We see a positive effect from both median upload and download speeds. Interestingly, the upload effect is almost twice the download effect, and then we see a negative effect on the stability. So the higher the range of internet speed, of upload speeds or download speeds within a local authority within a year, during working hours and working days, the lower the firm productivity is in average in this local authority. So consistent positive effects of median upload speed, non-consistent download effects. So there is some sensitivity here, and this led us to believe that controlling only for the internet speeds and ignoring the stability of the internet connections does not provide the full picture. Interestingly, as expected, speed instability negatively affects firm productivity. Let me try to add, some further interpretation here, and try to present our estimates using, real monetary terms. So, if we increase the median upload speeds in a local authority by 1 standard deviation, and 1 standard deviation is almost 3 megabps, based on our models, we should expect an increase of firm productivity by almost 600 pounds per worker on a yearly basis. So this might not sound as an important, improvement, but you need to also consider that a 3 megabps increase is something that users rarely are able to capture. So instead of presenting our results in a standard deviation framework, we try to build a more real world framework. So let's assume that we have the local authority in the UK with the worst internet infrastructure. And actually, according to our data, this is Mid Devon, as I mentioned before, in Cornwall. So if firms who are based in mid-Devon, this the local authority with the worst internet speeds, eventually, magically experienced internet speed at the same level as the local authority with the best internet infrastructure, right? That is Milton Keynes, to be more accurate. So this would have resulted in a 2% higher productivity growth, which is something that policymaker can more easily relate to. So I think it's important to highlight that for these results we have account for correlations within firms, given that we only observe firms over time within local authorities, as different places might offer more fertile grounds for firm performance. And also we account for correlations within SIC codes, within industries, because firms in specific industries might be more sensitive to the quality of the internet service they receive. So these are our base results, if you prefer. There are quite a few control variables that the previous regressions include. Maybe for the sake of time, it's better for me to move on. We do a few more things in our analysis. We introduce some interaction terms. So we interact the different speed and stability, internet stability variables. Sorry, we only do the interactions for the speed variables. We introduce a number of interactions between the different median speed variables, upload and download, with the size of the firms, like employment, with the age of the firms, and also with the job density in local of the local authorities that these firms are located. So the results, reveal some interesting pictures. So regarding firm size, it appears that larger firms are the ones which experience these positive productivity effects. And also younger firms are those who enjoy productivity effects, but these primarily come from the upload channel. Older firms, although they experience lower productivity gains, these gains come from both upload and download channels. And then regarding the location of firms, when we interact internet speeds with job density, we see that in urban areas, in more more agglomerated local authorities, productivity boost comes primarily from the download channels for firms, and this might be related, to services which have to do with, large files, content creation, etc., etc. We also split our data set into three different sectors: agriculture, manufacture, and services. The results in agriculture are a little bit more sensitive, more unstable, and this makes sense because it's more difficult to both capture productivity in agricultural firms, but also understand how internet can be used in these firms. And then, both manufacturing and services appear to have positive effects, with manufacturing effects being higher than the one we see in services, and this more or less in line with what we've seen elsewhere in the literature. And lastly, we do a number of robustness tests. I think it's maybe better to just quickly summarize that after we, manipulate our samples or the control variables in various ways, we see that, the upload speed channel, the effect from the upload channel, and also the stability of the download speeds, remains robust, unchanged, solid, while there is more nuanced when we focus on download internet speeds. We did some post-estimation analysis to see if there is a geographical clustering of the residuals of our models. No matter what we did, we were not able to find any such clustering. And last but not least, we try to discuss the causality element. So let me remind you that our local authority random intersets capture potential endogenous partial heterogeneity. So whatever happens within local authorities. Our firm and sector random intersets capture firm and sector heterogeneity. And we also include yearly dummies, which capture, high-level over time changes to the internet infrastructure. So based on our modeling framework, it is difficult to imagine any other pathways through which a reverse causality, might occur. So if it's not the context, like the local authority, the firm, or the sector, it's difficult to see how the reverse causality take place. So for example, how firm productivity will lead to increased internet speeds. And we have here, a few scenarios that we try to think if it's possible to lead to reverse causality, but we didn't, we're not successful. So for example, if one believes that internet service providers react to firm productivity and invest more in these places which are, which tend to be more productive, this is something that we already capture with our Placial effect, with our local authority random intercepts. Then, if someone expects that internet providers improve infrastructure in these places where innovation, is happening, we also capture this through our sectoral random intercepts. And then if somebody believes that productive firms use their surplus to relocate to places with faster internet, on the one hand, we capture this, with our place and firm random interface, but it's also difficult to believe that, firms will relocate, so will go through the cost of relocating only because of such to capture, to experience, a better internet infrastructure. We expect that this will happen, when firms are established, and we control for this. And this is my next meeting. Apologies for this identification, but it's difficult to see a scenario where such a relocation might be an important reverse causality element. So all in all, we test the impact of experienced broadband speeds on fair productivity in the UK during the 2011-2019 period. Importantly, we approximate business internet usage. Our headline finding is that fast upload and stable download speeds are those that really matter for productivity gains. These results are not uniform across the economy. And to close, we believe that this digital environment approach offers support for place-based internet upgrade policies. Thank you very much for your attention. Happy to answer or try to answer any questions.
Thank you so much. It was really inspiring, really interesting research. Thanks.